Yeah, I'm here to detail about the experiment based on spring test. The name of the experiment is combined compression and extension of springs apparatus. So we are going to test a spring and we apply the loads axially and then we see the deformation. The force per unit deflection is known as the stiffness. So objective of this experiment is to determine the stiffness of spring in tension and compression. As you can see, there are two springs in my hands. So easily we can identify, say this is for the two springs are there in my hands. This is the spring and one can identify whether it is for tensile test or compression. So you can see there are two rings at the both ends so that it can be held properly for the tensile test. And the another spring, so here only compression is required. So this spring we can identify, this is for the compression. Regarding apparatus setup, so one can see the setup of the spring. This is the hook and hanger is attached with the hook and the loads are attached with the hanger. This is the rod. Hooks are at both the ends and one can see in between there is a thread. So it is for the arrangement of compression. And in between two hooks, the spring, a setup of spring, that is for the tensile test. At the end, this is just to give support or adjust the, you can say whether we have to give tight more. So accordingly we can set it. This as this setup is dedicated for the both the test, the spring in tension and compression. So this setup, initially both two springs are there. This is for tensile test and below one for the compression test. And with the hook, hanger is attached with some loads, 1 kg load. Now I am preparing it for the test of spring in tension. So this I am going to remove. The hanger is now removed. Now I am going to remove this spring. So yeah, it got removed. Now I am going to tighten it by rotating it clockwise. Okay, and this is the main scale, and this is the vernier scale. So I am going to adjust so that zero reading of vernier and main scale both should be matching. So it is matching. For that, what I have to do, I have to So where both the zeros on the main scale and 1 scale are matching, and then we are tightening the nut at this stage. So regarding observation, how to take the observations means what are the data required so that one can complete the test. So this is the observation table. The heading is stiffness of spring, and one can see serial number column. Then loads are there starting from 1 kg, then 1.5 to 2.5 and so on. Means we are going to increase the loads by half kg, and then taking readings. Suppose we are increasing the load, and similarly after putting a 5.5 kg, then we have and deformation, increasing for the increasing loads, decreasing loads, and then we have to take the mean value here we have to write, then stiffness of spring. So directly we cannot get from here, from the calculation load divided by deflection, then we will get the stiffness of spring, and then we have to average of all the 10 observations values of stiffness of the spring, and similarly the value of G. As we have seen the data required for the observations, like mean K, stiffness of spring, and mean G. G is here rigidity of the spring. Means G modulus of rigidity of the spring, and K and G both are directly related to each other, as K is the stiffness load per unit deflection. Suppose spring has more stiffness. What is the meaning of this? It means there will be less deformation. Generally it is जनरली बोला जाता है ना कि कुछ फ्रैक्चर हो जाने पे, लिगामेंट फ्रैक्चर हो जाने पे, कोई नी फ्रैक्चर हो जाने पे आपका बॉडी स्टिफ हो गया है. सपोज knee of one leg got fractured, so that knee we will be not able to use, so that will be means that will be not in use, so other legs will be using. So what happened that the leg which is not going to be used got stiffed, means stiff हो गया है. डॉक्टर बोलते हैं कि आप, इसीलिए बोला जाता है कि आप एक्सरसाइज करते रहिए, जहाँ भी कुछ फ्रैक्चर हुआ है उसको आप एक्सरसाइज करते रहिए ताकि स्टिफ ना हो. स्टिफ हो जाने पे फिर उसको यूज करना, प्रॉपरली यूज करना बहुत पेनफुल होता है, पेन होता है. So how G and K are related? One can see it is the G is equal to 64 K R cube N divided by D to the power 4. So R is what? R is the mean radius of the spring. You can see here, and means the outer diameter OD minus the diameter of the coil wire. outer diameter minus ये आपका outer diameter हो गया, and diameter of the wire. Then we get the mean radius. Then we get mean diameter of the spring. and if we divide by 2, then we get mean radius of the spring. So in this way we have seen the relationship between the G and the K. In that equation there is a term N, capital N. So what is that? That is the number of turns. You can see here, like this is the one turn, then second turn, third, fourth, fifth, sixth, and so on. Regarding the length of the spring, so suppose it is not in compression or tension, so then it is known as the free length of the spring. And suppose it got compressed fully, then the length is known as the solid length. This is the hanger with 5 kg of load, and now I am going to put it here, and after providing half kg, so there will be, actually there is a 1 kg of load, half kg and including half kg of hanger. So 1 kg of load is there, and then we can see the deformation, but there will be not so significant deformation. So to observe it properly, we are going to increase the load. As we wanted to see the deformation clearly, hence directly 2 kg of load is kept here, and one can see the deformation. This is the S, the main scale, and this is the vernier scale, and one can see where it is, where is the 0.
As you have seen, after applying the load of 2 kg, there is some deformation showing in the scales, and we are going to note down the deformation from this main scale and vernier scale. So as we can see, this 0 line is coinciding, 0 marking of VSR is coinciding with second division of MSR, main scale reading, and as we can see, there in main scale reading there is a reading of 2 mm, and similarly we can see the divisions number of 6th division is coinciding with the division in main scale. So as we can see, there is a main scale reading is 2 mm, and as we know, the full reading of this scale is MSR plus VSR into list count, and we know this is a simple vernier caliper kind of apparatus. So then its list count is 0.1 mm here. So in that case, the total reading will be 2 mm in MSR plus 6th division into list count 0.1 mm. Then total value is 2.6 mm. The first value for first observation, deformation of tensile spring is 2.6 mm here. As we have seen here, we have take the notation of extension of this spring, tensile spring, for 2 kg of load, and we have to perform different number of observation in this manner. And in the observation table we have seen there are 2 types of loading for which we note the deformation. One for increasing loading condition. So right now I am doing the experiment for increasing loading condition. So we have to increase the load by 0.5 kg each time, and we have to take the notation up to 5 kg of load. And in the similar manner, we have to take the elongation in the tensile spring under the decreasing loading condition. So for that, we have to remove the load one by one, 0.5 kg load one by one each time gradually. So as we can see, once we remove the load, then this tensile spring is regaining its shape and we get the deformation. As earlier at 2 kg we have a deformation of 2.6 mm. Right now we can see here also the MSR is 2 mm and VSR is 7 mm. So in that case, the total value of this elongation is 2.7 mm. So as we can see from these observations, that for increasing loading condition at 2 kg of loading we have a deformation of 2.6 mm. In similar manner, for decreasing loading we have a deformation of 2.7 mm. So we can take the mean values of these two deformation for calculating K, that is the stiffness of a spring. So that's the process for conducting the experiment for calculating stiffness of this tensile spring. As we have conducted the experiment for tensile spring, for calculating the stiffness for tensile spring, now we have to make ready this setup for compression spring. Stiffness, for calculating stiffness of this compression spring. So for that we have to remove the tensile spring and arrange this compression spring in the setup. So for that we have to remove the hook and we have to insert this compression spring here.
We are going to insert the spring for the compression. Then we have to remove the spring that is on the top for the tension. As simultaneously we cannot perform both the tests, both the modes for the spring. So the top spring is now removed.
Okay, as we can see here, this setup is ready for conducting the experiment of compression spring for calculating its stiffness. As we can see here in this setup, this compression spring has some initial deformation. That we have to take note of that deformation, because for the observation we have to minus this initial deformation in every observations to get the actual deformation under the applied load. So as we can see here, this zero marking is coinciding with 1.1 mm, that means 11 mm. Here MSR of this division is 11 mm and VSR, 7th division of VSR is matching with main scale division. So in that case here 11.7 mm is the value of initial deformation, initial compression deformation of this compression spring. Then we have to subtract this value from each observation for calculating the stiffness K. And I have to apply a load of 1 kg, that is the value for first observation. Then for first observation, now I am going to apply a load of 1 kg here. As I have applied a load of 1 kg, and we can see there is some deformation in the spring, in the compression spring, and from the scale we can see the 17 mm is the reading of main scale divisions, and 4th division of VSR is matching with main scale division. Then in that case here a value of 17.4 mm is the deformation for the first observation in the compression spring. In this manner we will raise the load by 0.5 kg each time up to 5 kg of the load, and we will conduct the measurement of deformation for increasing loading condition. In a similar manner, for taking the observation of decreasing loading condition, we have to remove the load one by one and count the values, measure the value from this scale accordingly. That's the process for doing this experiment and taking the observation. And for calculation purpose we have the formula, and after that, after taking the observations and calculating the value of K and G, we have to plot a graph between load and deformation.
Regarding application of spring, there are various applications. You can see the functions of the spring, like it is used to restore the energy and release it whenever required. You can also see in the railway there is a just near the wheel there is a spring system, also used in automobiles, in a scooter, bikes. I have two shockers, so there are springs inside, and you can see the role of this. Like I am going to compress it to see what is happening here. Yeah, it is a suspension system, and I am applying some force, and it is the coming back to its original position. However, from the scooty point of view, it is not working properly, means it is not able to resist the shock. That's why it got replaced. As one can observe, while doing experiment, we are increasing the loads slowly by half kg, and in the another setup of the experiment we are decreasing. So it is spring is the elastic material, so it should regain its shape. So to check that whether in the increasing load we are getting whatever we are getting deformation is able to regain its shape or not. So for that purpose, that both increasing and decreasing way of the testing is done. Yeah. As after taking observations, now we have to plot the curve. So for the increasing load, means for the tension mode, so there is a graph between the deflection or deformation, you can see, on the horizontal scale, and vertical axis there is a load, means the deformation versus load, and we get this type of, you can see here the curve, and these dots are the number of, it indicates the number of observations, straight line we are getting, and one can see here, because the load is started with the 1 kg, that's why deformation here the curve starts at 1 kg and the corresponding deformation. So like this 1.5 kg, then we can see the deformation on the horizontal axis. Similarly at 3.5 load, 3.5 kg load, and the corresponding deformation one can observe here. It is 24 mm. Similarly, for the compression, again the deformation versus load, vertical axis load, horizontal axis deformation, and the similar way we can plot the graphs. Thank you.